Alright everybody, here we are, and this is the last time when I'm actually gonna be talking about this particular session. There's a little code remaining, so we will be going through that particular code and seeing exactly how the things going on there, and that's it, nothing else. So without any further delay, let's simply get this thing done, and that's it. And as for now, I'm mainly gonna be focusing on this particular part over here. So this is the code that I actually wrote over here. What I'm doing, first of all, I am creating many workers. Ultimately, if I have 10 cores, so I'm creating 10 workers, and there is a calculation that I'm doing from 1 to some 1000 million times, and I'm just simply gonna be adding all those things together and gonna be calculating the sum of all those things. But let's see exactly how much that's gonna be. And for that thing, it's not like only because I'm calculating the sum from 1 to maybe 1000 million. It does not mean that there's gonna be only one process. Rather than I'm gonna be creating many workers, many processes, and the workers will have a chunk of that whole process. So maybe from 1 to 100 million, then 100 million to 200 million, and this is how they will be calculating the sum. And once they have calculated the sum, we will be just adding all the stuff and then returning that. As simple as that. So first of all, the chunk size, we have the target, like we have 1 million, and then suppose we have 10 core CPUs, though I don't have, but suppose if I have, then 100 million per core. So one core will have 100 million. This is how 10 cores will have 1000 million. So this thing, chunk size is decided, and after that I will be running this particular part will be run for the first time. So start time, forget about these ones, these are just for the time related stuff. The main thing starts from here. Total sum is gonna be 0. Completed workers are gonna be 0. Okay, there are gonna be, if there are 10 workers, then all of them needs to be used. After that, let I number of CPUs and something like that. So ultimately, I'm using workers one by one. So first of all, what I'm actually doing over here, I'm actually creating the workers on the basis of the number of the CPU cores that I have. And once the worker is actually forked, then I'm calculating the starting point and the ending point. So starting point is gonna be I multiplied by chunk size. Chunk size is 100 million for one 100 million for one core, right? But I am gonna be dividing it by 0. That simply means it will be starting with a 0, and it will be going till if I dot I, if that's triple equals to number of CPUs. That simply means this particular index becomes the equals to the number of CPUs, then I minus 1. In that case, it's gonna be target in the sense of 1000 million, and otherwise I plus 1 multiplied by chunk size minus 1. That's obvious. Chunk size is 100 million. I plus 1, that simply means that 1 to 99.99 million, something like this. Okay, so it will be just divided by like this. So I'm just simply creating the starting point and the ending point. It's simple. If that's equals to number of CPUs, that means the target is gonna be the ending point, the last one. Otherwise, I'm just simply gonna be adding 1 to the current index, the index that I have, and that chunk size will be kind of subtracted by 1, and that's it. Subtracting it 1 because I don't want to have that 1 to 100 million. Rather, I want to have 1 to 99.99 million, something like that. And then when I started from 100 million again, and that is why I'm just subtracting minus 1 from here. That's it. This particular stuff, I mean, by default, it does not actually send the values of the worker.send doesn't really work. Maybe because by the time it is called worker, I mean, folks haven't been created yet, but this did not really work. We will be checking whether it works or not. And once this particular thing is done, I am sending that. Then in the remaining process, I'm just simply handling the things here. So ultimately, this particular part will run, once I run this particular file, forks are going to be created. Once those forks are created, then I'm gonna be sending, once I have actually created the fork, that means this particular file will run again. Not only that, as I have decided the starting value and ending value, so once the fork is actually created, that simply means another process is running right now, and I can just simply send the values from here to that particular fork. Once that fork will get the value over here, process.message on. Once it gets the values, it will just simply calculate that and return from here. Once it actually returns, that's it. You will be getting the result over here. So message, you will be getting that. You will be adding to total sum, and that's it. You are just simply gonna return. And then the new fork will be created. Then new start and end will be kind of created, and then it will be sent again. This will get the message again, it will just simply process that, calculate the sum, and this is how things are gonna be done. Having said that, forks are gonna be created kind of instantly, and this worker.send will happen to like kind of synchronously, but really quickly. And once all these things are done, and then this worker.on message will be waiting for the messages from this process.on message side. So this worker.on message is actually waiting for the messages from the process side, and this process.on is actually waiting for the messages sent from the worker.send side. So this is how the things actually go on. Didn't really want to talk much about them, so just got it done really quick. Having said that, I do have it in my notes, so I don't really need to worry about them, so, especially when it comes to the notes. So where am I supposed to be? Inside this one, horizontal scaling, vertical scaling, and over here this is the GitHub profile that I actually have, and I have actually just pasted all the code here. So example 2 index.js. Here what I'm doing, I'm calculating the same stuff, like I'm calculating the sum from 1 to 1000 million, but in this case, or I can say 1 billion. But what is actually happening over here, this is a single threaded process. Single threaded process in the sense there is the one process, you are just simply starting a for loop and just simply calculating everything, and at the end of the day just simply logging that. So this is a single threaded, one core will be used up. But when it comes to the another one, like example index.js, here you are actually creating, first of all, the whole calculation, the whole process you are dividing into chunks. So like 1 to 100 million, from 100 to 200, 200 to 300, 300 to 400 million, something like that. And once that is actually divided, then you are actually creating the forks. Not only that, once the fork is created, like where am I creating the fork? Just a sec. Okay, so here the fork is actually created. Fork in the sense worker is created. Once the worker is created, now you are just simply sending the starting point and ending point to that particular worker, that okay, you are the worker, now you have to handle the things from this particular time to this particular time, for this particular point to this particular time, you have to get the job done, get it done, and then give me the response. So this worker just you send the message from here, the message is received over here, and once the message actually received over here, you calculate the sum. Once the sum is calculated, you simply return process.send, and you just simply return the partial sum. Once the partial sum is returned, that's it. Then you are waiting for the message over here, worker.on message, you are going to be getting the message. Once you got the message, that's it. And again this end time and all these things are completely optional. The thing is that the most important thing is that you are actually calculating the sum, and lastly you are just simply logging the total sum. This is how the things are gonna be going ahead. Why not just rewrite the code on or on, and let's see how much we are gonna be able to accomplish it. Like okay, so far the code was pre-written and I was able to explain that. How about rewriting the code? So let's do one thing. Inside this test.js, first of all, let's see whether we can actually accomplish this or not. The goal is pretty simple. Have to create the goal is that I have to calculate the sum. Calculate the sum from 1 to 3, 1000 million. Okay, there are two ways. The first 1 billion, yeah. So there are two ways. One could be that I'm gonna be calculating it single threaded way. That means the process will be running only one core, and let's see how long it's gonna be taking. So for that particular thing, this is gonna be test2, and or let me rename it single threaded process, just like this. And I will be creating another one that's gonna be multi. It's better to do it on or on, right? Multi-threaded process.js, because sometimes it's easy to explain, but like if something's written, but when you do it on your own, things get difficult. But let's see how it's gonna be going on. First thing, this is gonna be single threaded. Having said that, let or const, what is the target? The target is gonna be, or value, depends on it, whatever you wanna name, you can name it. The target is gonna be 1 2 3 1 2 3 1 2 3. Having said that, this is gonna be single threaded. Once I have the target, then what else? Nothing else. Once I have the target, and the next thing is that I will be getting the length of the course. I mean, I will be getting the course of my CPU. So const, I can name it course, or number of CPUs, depends on you. It can be anything. I'm just naming it number of CPUs or number of cores. How about this? I mean, this is not bad either, right? Ultimately they are cores. I have it course and all. So I'm gonna be having number of cores, and that's gonna be OS. So I have to import OS as well. So import OS from OS, of course, once I have the OS. So os dot cpuj, it actually has a method called cpuj. It actually returns me all the methods. So let's name it number of cpuj, because that's the kind of method that we are using, right? But this will only return me the number of all the cpuj, but I actually kind of all the cpuj it will return, kind of cores it will return, and I want to have the length of that. So let's even first of all log it, number of CPUs. It will just simply return all the CPUs, not even the number, because we will have to take care of the length for that. So node, and that's gonna be test, not single threaded, and it is returning me this much. So ultimately, one, it has model, speed, times, and all. Ultimately, these are the cores that I have. So 1, 2, 3, 4, 5, 6, 7, 8. So ultimately these are the cores that I actually have. So ultimately what I can do, dot length will actually just simply give me the length, and if I run it again I will be getting it over here. That simply means I have 8 cores. Okay, now the question is that how much can one core how much should one core be handling? So const, and that's actually gonna be chunk size. Like, what is the chunk size for a core? So I can say minimum. I'm just simply gonna be getting the minimum, like this is the minimum amount it should be just simply calculating. And for that it could be target divided by number of CPUs, as simple as that. So number of, if 8 divided by 1 billion and all, so one CPU will be handling some chunk of the process, and this way the whole process will be divided into chunks, and those chunks will be given to those cores or workers separately, so that one core doesn't have to handle a lot of stuff. Once this particular thing is done, then that's it. If OS, not OS, what can I say? What am I gonna be using for forking? I'm gonna be using cluster over here. So cluster, from cluster, that's amazing. And let's by default, if I'm gonna be running, this is the master process, main process you can say, and when I run it for the first time, at that time is primary is actually gonna be true. So for the first time this particular part run, and in the remaining case this particular part run. So let's take care of this one. When this particular part is actually running, at that time, what else? When this particular part is running, this ran for the first time, at that time the value of the sum is gonna be 0 for sure. And what else? Let's see, whatever we require, we'll get it. After that const start value I'll have to calculate. Start value is gonna be not even start value, because the start value should be calculated on the basis of the targets, the workers that I create. So let's create the workers for right now. So let I is gonna be 0, I should be less than number of CPUs and I plus plus, and then I will be creating the workers. For creating the workers, cluster dot fork, it will just simply create the worker. Once the worker is actually created, now I have the worker. Once and having said that, where will I be getting the worker from? Worker, can I just simply name it worker dot on, right? It may work directly. Yeah, it does work. So it is directly available over here, that's fine. So once the fork is actually created, that means this file will run again, and when this file is running again, so at that time this particular section will run. So this will run after the fork, as simple as that. But once the fork is created, it needs to have some values, right? And that's what I'm gonna be sending from this particular section side. So start is gonna be 0 by default, 0 to some values. So I can simply say that I multiplied by chunk size, as simple as that. So that's gonna be the starting value, 0 to maybe 99 point some billion. I mean, ultimately I cannot go directly to 100 million, though I can go like 1 to 100 million, then 101 to 200 billion, then 201 to 300 billion. This is also a way. Let's even do that. I mean, it's completely up to us. So for this particular thing, I will actually have to start it from 1. But okay, never mind. Let's continue with this one as well. But 1 to 100 billion. Let's go with this way too. I'm gonna be starting it from 1. It's gonna be equals to this 8 CPUs. I'm gonna be adding some my extra logic over here. earlier it was starting from 0 to 99.99 billion type something, but what I'm gonna be doing over here, I'm gonna be starting it from 1 to 100 billion, and the next time 100 billion 1 plus to 200 billion, something like that. This is the way that I'm gonna be going with. So start is gonna be I that is equals to this time 1 multiplied by chunk size, that was already 100 billion. If I, in case the assumption is that I have 10 cores, okay, though I don't have, but just for making the calculation easy, I'm just assuming it that I have 10 cores. That simply means I'm gonna be handling 100 million requests per core. I only have 8 cores, but okay, the logic is simple, right? It should be working for it 8 cores as well. So start part is gonna be this. As for the end part, so const end is gonna be, first of all I will have to check whether the index that I have, that is actually equals to number of CPUs, that means that is the last index or not. So I triple equals to number of CPUs. If that's equals to, still I'll have to just create a cluster. That simply means I'll have to check if that's greater than number of CPUs. If that's actually greater than number of CPUs, in that case what do I have to do? In that case the target value that I have, that itself is gonna be the end. Otherwise I will have to create the target. I will have to create the end, and when creating the end, that's gonna be I, that I already have over here, plus chunk size, and I plus chunk size plus 1. Will it be fine? Not really. I will have to multiply it by 1. Add it 1 multiplied by chunk size. This is how it should be fine. So what I'm actually doing, suppose initially I will have the starting point over here, chunk size. No, that's crazy. It's directly I have to start it from 1. Okay, just a sec. Let me be explicit over here. I'm gonna be starting it from 0. Okay, it will go till number of CPUs, and after that the starting value is gonna be I chunk size plus 1. Let's make it like this. So 0 multiplied by chunk size, that means 0 again plus 1. So it will be starting from 1, and the ending value is gonna be, if let's make it equals to, right now this time I is equal to number of CPUs. In that case the end value is gonna be target. The end value is gonna be target. Otherwise the value is gonna be I plus 1 multiplied by chunk size. That simply means I plus 1. So 0 plus 1 1 multiplied by chunk size, that means 100. So why do I need to add it over here? I don't need to add it. So this is how. So 1 multiplied by 100, that's actually gonna be 100. So the first time it is okay. What if the value of I is gonna be 1? So 1 multiplied by 100 plus 1, that simply becomes 101. So initially it is 0, and it becomes 100 for the first time, if I'm not wrong. So I is gonna be 0. So 0 plus 1, that simply means it becomes 1. And as for the ending value is gonna be 0, then not target, then 0 plus 1 1 multiplied by 100, that means 100. That simply means it becomes 1s. So initially the value of start is 1, the value of end is 100. The second time, let's make it optional like this, like comment it for now. And the second time, once the value of I becomes 1, then 1 multiplied by 100, that means 100 plus 1 101. So the next time the value of start is gonna be 101, and the value of end is gonna be 1 plus 1 2 multiplied by chunk size 200. So this is how it's gonna be going on. So 1 start end 100, 101 start 200 end. Similarly 301 start and not really, 201 start, not 300. 201 start and 300 end. Let's even check this. If the value of I is gonna be equals to 2, so 2 multiplied by chunk size 200 plus 1 201, and then 2 plus 1 300, 3 multiplied by 100, that's gonna be 300. So whatever we wrote, that is right. After that we can just simply continue from here on. So we have the start, we have the end. After that, what do we want? Now we want to send the start and ending point to the worker. So I can just simply say worker dot send, and what I want to send, I want to send the start value and I want to send the end value. That's it. And now this worker will be handling the stuff. The worker is actually gonna be here, so I can just simply say process dot on. It will be listening to the messages and it will ultimately get the message. Once it got the message, I will be just simply logging that message over here, and let's see exactly whether this works or not. Interesting stuff. So fork will be created, starting and ending point, sending it to the worker. This will trigger, and then I will get it here. Let's simply run it. For running it, this is not gonna be what the hell. I was supposed to be writing the single threaded code, but I actually wrote the multi-threaded code. Sorry for that. This should actually be in this particular section, multi-threaded code, and let's run the multi-threaded process. So node multi-threaded, run it, and the requested cluster does not provide the export named worker. Sorry. The worker is coming from here. If I just remove it from here, what will happen? Let's see. It will just simply say that bro, worker does not exist. Worker dot sender. So it is simply telling me that worker does not exist, and that is right. How am I going to get worker? Good question. How do we get the workers? I have created the cluster, that is okay, but I'm using worker over here. Where is this worker coming from? That's interesting question. Can I get a cluster dot worker? Will it work? I didn't really mention it. That is why we should write the code on our own. No. Where does the worker come from? Ultimately, I will have to fork is created. That means worker got created. Can I do it like this? Let worker is gonna be this. Will this be okay? Oh yeah, it did work actually. So ultimately I do get the worker from this cluster. So this cluster.fork actually gives us the worker. Using that worker you can send the values, and this value is gonna be given here. But let's see exactly what we get in the console. So starting value is this, so I'm not really gonna be worried about that. 1 to 125. 125 billion. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6. So forget about this 100. 1 2 3 4 5 6. So I have 125 billion. Sorry, million, not billion. And it is not exactly the same. What could be the reason behind it? The reason could be ki I'm getting the minimum value. Okay, got it. I don't have 10 cores, right? If I had 10 cores, in that case, kind of the chunk size could have been 100 million, right? But right now I have only 8 cores, and that because of that thing, the chunk size is actually from 1 to 125 million something. So that is understandable. Having said that, if I had 10 cores, then this 100 million formula actually applies. So from this to this, so 1 2 3 4 5 6 7 8 cores are there, 8 chunks are there, and now those separate chunks will be handled calculated separately, and then at the end I will be adding the stuff. So that's great. Once I got the stuff over here, then I will be getting the starting point, I will be getting the ending point from the message itself. Once I got that, then what will I have to do? I have to just calculate the sum from there to there. So let partial sum is gonna be equals to 0 by default, and for let use for of. Can I do that? Nope, I can't. For let I is gonna be 0. I should be less than what? I should be, first of all, I should be start, first of all this, and then I should be less than equals to end I plus plus, and ultimately I have to calculate the sum. So that partial sum is gonna be plus equals to what? Start, as simple as that. And then at the end of the day I have to return it. For returning it, process dot send. Do I have send? Yeah, I do have that. and then what will I be sending? I will be sending partial sum, and that's gonna be equals to partial sum. I'm just simply gonna be sending it like this. So far so good. Once I'm sending it from here, I will be receiving the value here. So worker dot on message, worker dot on message, I will be getting my message over here. I just simply wanna check whether I'm actually getting the message or not. So message, let's simply see. Ultimately I should be getting the sum. Okay, sorry, I did get the values here. So I can have some comments here. Okay, never forget about the comments. I am getting the partial sum over here. So ultimately I'm getting all the partial sums, and once I'm actually getting all the partial sums over here, what can I do? After that, once I have the sum, then total sum, do I have total sum? Sum plus equals to message dot partial sum. This is how it should be going ahead. So I have the sum over here, but at the end of the day I will be calculating all the sums, and then once everything's calculated, once everything is calculated, what will I be doing? I have to log the value. Where will I be logging the value? This message dot on will actually be, Kalam yaar, I'll have to go again. Okay, just a sec. Will it be called again and again? This message, whenever it just simply returns something, whenever it process sends something, worker will get that, and once the worker will get that, CLG, let's see, sum is gonna be equals to sum. Gonna be trying it out again. Oh bro, what is the problem? Worker dot on worker send some, it should be fine. Multi-threaded job.js, error event and handle error. Error event worker instance. If I did not have this, then I'm still getting it. Why am I getting this? One more thing. Am I not exiting it? I can have one thing here at the end of the day. Cluster dot on exit. If it actually exits it for some reason, in that case I have to just populate a new cluster, kind of fork a new cluster. That's fine. But CLG message, just a sec, let's see what kind of data I'm actually getting here. So this is kind of the data that I'm getting. So if I actually try to get the message dot partial sum, then what will happen? Yeah, I am getting that. And if I actually want to, okay, let the worker const sum, great job, let sum. Such a great job I've done here. Never mind. Let's see how it's gonna be going on. Yeah, as expected, I am getting the result, but at the end of the day, it's quite vague. Like it's being printed over and over. So what can I do? In order to print it at the end of the day, whenever the cluster exists, maybe cluster is never gonna exit, it will never print. So what can I do? Okay, the thing is that cluster is never gonna exit. This worker will be getting the messages and all. So can I do one thing, that I will be printing the sum at the end of the day. Let's see, CLG sum is gonna be equals to sum. Let's see whether it works or not. Sum 0 0 0. No way, I'm not getting the right way to, like I am getting the sum, I am getting the message. Now I have to print the sum at the end of the day. So I can even do one thing, like instead of having sum over here, right, instead of having sum over here, I will actually have the sum at the end of the day here, and it will not work, because even if I'm printing the sum over here, it will be just simply logging the value. Yeah, as expected, it is doing the same thing. So even this will not work. So how am I gonna be printing the value of sum? Let's keep the sum here inside this only. And now if I want to print the value of sum, in that case, this is the loop that I have. CLG, is this even gonna be possible? Just trying some things out, never ever. So ultimately if I directly run it, it will never run. And when I'm running it here, whenever I'm getting the message, I can do one thing. I can actually calculate the number of number of used cores, or used cores. By default it's gonna be 0, and as soon as fork is created, used cores plus will be add one core will be added, and ultimately over here I can check if used cores triple equals to what? Used cores triple equals to number of CPUs. In that case, CLG sum is gonna be equals to sum, as simple as that. Now this should work. Yeah, literally used cores, if that's triple equals to this, CLG used cores, number of CPUs, 8. Okay, fine. Why is this it? Because this is inside the loop, obviously. Let's see. So ultimately once it is actually inside the loop, it will never ever run that until analysis is equals to number of CPUs. One more try, and I think this should be working. 8 by 8, sum is 0, everything's fine, but sum becomes 0. Why? Because where is sum? Sum is here. I'm still inside the loop. Okay, how can I get out of the loop? Somewhere here. So this is the loop that I have. It is just simply calculating the stuff and all, and that at the end of but even before that, this needs to be somewhere at the top, that is already there. Let's see whether this works or not. At the end of the day, I do have. Why am I not getting the sum? This sum, I should definitely have it inside my message, otherwise it's never gonna work. So Control X, whenever the last message is triggered, at that time I have to just log the value of it. And not only that, as for this sum value, this should be here. Fine, quite okay. In that case, I am getting the sum, but I am getting it many times, because the value is kind of equals use this course. Yeah, that's obvious. So instead of using used course over here, I've even forgotten what I was explaining earlier. I'm just using my own way here, but okay, never mind. The thing is that whenever I get a message, that simply means that particular core got used, so I will be adding the value here, and here we are. Too much, but fun. So ultimately what is happening, that as soon as you get the message, then you can say that core's job is done, right? If you created the core, it does not mean that the core got used. So once the core actually got used, that means the core, the worker used the core, using the core got the job done, and you actually got the response of the job. At that time you can say that that core is used right now, and then at the end of the day you can just simply log the values and all. Let's have a look at okay, single threaded is gonna be easy peasy. I will be writing it soon, but I have to go to the field side right now to get the work done. Otherwise that's gonna be too bad. But before that, let's have a look at it quickly. Not this one, yeah, not this one. Example 2. Okay, here we are. Worker is here. Okay, thankfully I got the worker from here. Set timeout. Wow, even this thing is getting done. That's amazing. Nothing could be better. And then worker.message, total message. Yeah, here we are, completed workers or used workers. We are just adding the values here, and nothing else. Everything else is fine. One more thing that I have to know more about it, like this particular crazy stuff, console.time end automatically gives you the time. I'm gonna be checking this thing out too after I'm back from there. So take care. I don't know how long have I been live. 35 minutes, 5 minutes is stuck. Never mind. I'm gonna be catching up soon. Until then, take care and see you after 15 minutes. Take care.